Good afternoon. The purpose of this video is to show you the proper way to use the graphing calculator to solve a system equations. This will help check your work when making sure that you have arrived at the correct solution for the system. You will be required to work everything out. I'm just showing you how you are to check it if you would like to. Okay, so the way the graphing calculator solves these is by using matrices. And so we're going to talk about matrices Monday, but I'm going to go ahead and talk to you about this. Alright, so you want to set this up as a matrix, okay? You did this last year. So I'm going to just draw for you what you're going to input into the calculator, okay? This is what the matrix you're going to create in your calculator. The coefficient in front of x is 2, coefficient in front of y is 3, and then 9. Down here will be 5, negative 1, because it's understood 1, and 14. So this is the matrix that you will input into your calculator. Okay. Okay, I'm going to go to, let me zoom this out for a minute so you can see. Okay, there's the matrix right above the x sub 1. Let me zoom out some more so you can see that, sorry. Or, hold on. You see right here the word matrix. That is where I'm going. This button is second. This button right here. Okay? So, I'm going to hit second, that button. And when I do, you see, I have names, math, and edit. I'm going to go over here to edit, and I'm going to click 1. I'm going to hit the first matrix. I'm going to edit that matrix. Well, you're going to tell what type of matrix it is. Remember, you name matrices by dimensions, and dimensions are row by column. I have 2 rows. Rows go first. I put 2. By column. 1, 2, 3. Row by column. Row by column. Then you input your numbers. Hit enter. Keep inputting. Okay, once you're done with those, you're going to hit second, quit. See quit, so you're going to hit second, quit. Now, you're going to go back to second, matrix, and you're going to scroll over to math. Okay, and you're going to scroll down your calculator till you come to something that says RREF. RREF. That stands for row echelon form, and that's what we're going to use. You don't have to know that, but that's the button you use, RREF. You're going to hit enter, and then you're going to go back in your matrix, second, this button right here, and pick the matrix you were just working with, A. Close the parentheses, and when you do that, you get something that looks like this. So I'm going to write that down on this paper. You get 1, 0, 3, 0, 1, 1. Okay. You're going to see in this that you get something that looks like that, a diagonal of 1s. That's what you're looking for. You say, what does that mean? That 1 is sitting where you inputted the x, because this was the x. That lets you know that the x value is equal to this number. Wherever the 1 is sitting, that is, like this is for x, so that means x equals 3. The 1 is sitting in the y spot, so your y value equals 1. So x equals 3, y equals 1. So your ordered pair will be 3, 1. That is the solution for this system. You said, Mr. Scherzer, what if you had x, y, and z where you would have something that looks like this? You would have a diagonal ones there. The 1 is sitting in the x first spot, y, z, and whatever numbers over here, that's what x would equal. y would equal z is equal. If you don't get that perfect one diagonal down there, then it is either no solution or infinitely many solution. I'm going to talk about when does that occur. Let's look at number 2. Let's set up how we're going to do this matrix. Okay, your x value coefficient is 1. Do you notice that others have y, this one does not have y, so you've got to put a 0 in for y. Then negative 3, 7. 2, 1, negative 2, 11. Negative 1, negative 2, 2, and 6. The dimensions of this is 3 rows by 4 columns. So 3 by 4. So you're going to go back. Second matrix. I'm going to edit the first one. I'm going to edit, and I'm going to change the dimensions to, what do we say? 3 by 4. And then input my values. So I'm going to input those now. Should remember doing this last year, because we did do this last year. Make sure you inputted the correct numbers, so if I can make mistakes. Alright, now I'm going to hit second quit, go to matrix, and scroll over to math, and then scroll down to RF. Go back to second matrix, pick my matrix. And look at that. Do you get that perfect diagonal of ones? Yes. So this one is sitting to x, x is equal to 10. This one is sitting to y, y is equal to negative 7. This one's sitting in z, z equals 1. So, your ordered pair would be 10, comma, negative 7, comma, 1. X, y, and z. Alright, let's look at number 3 and the last one. If you need to pause it, you can pause it at this point. Alright, let's talk about how we would build this matrix. 1, negative 1, 5, negative 2. 2, 1, 4, 2. 2, 4, negative 2, 8. So that is row by column of 3 by 4. Okay? So I'm going to second matrix. Over to edit. I'm going to change the numbers. It's already 3 by 4. So I'll just go 1, negative 1, 5. Now I'm going to go to second, do the matrix again. Over to math. There's a lot of things that you can do, and you'll learn more what these buttons do later on when we study matrices next week. Hit B, RF, go back in and pick my matrix. Alright, so let's notice what happens here. We didn't get that perfect diagonal of ones. This is what we got right here. We didn't get that perfect diagonal of ones. So this is either no solution or all real numbers. What you do, guys, is you look at these last two. Look at these last two. Does that equal that? That does equal that. That is 0 equals 0, so it's infinitely many. She said, Mr. Esther, how would you know if there was no solution? Let's say it was like 0 equals 5. Or so if these two numbers were not true statement, if 0 didn't equal 0, if this was some number equals some other, it would be no solution. That's how you would tell in the calculator. Hope that's the easy way to check your answers. Well, once again, you will have to work everything out to receive credit, but you can check your work like that. See you next week.